Hey guys, so tonight we're going to talk about some functions. So the purpose of this was to just show you the graphs of these functions and such, and just tell you a little bit about it. So for instance, linear functions is the rate of change is constant throughout, and because of the slope. And straight line, they are usually straight line graphs, and they're used to describe things such as distance. And the standard form is ax plus by equals c. And here is also a picture of what the typical linear function looks like in a graph. So next is a quadratic function. So sorry if you can't see the picture because of me, but it's usually a parabola, and the form is ax squared plus bx plus c. The domain is a set of all real numbers, and the range is a set of all real numbers, but only those that satisfy the equation. I'm sorry for the typo that I have right there. Then they also determine the number of roots using b squared minus 4ac. If the value is positive, there's 2 unique roots. If the value is 0, there's only 1 root. So next is polynomial functions, and as you can see, this is a graph of one. So a polynomial function is a function with multiple terms and powers of x. As you can see, I know it's a little blurry, but in this function right here, you can see that there's x to the 5th, x to the 4th, x cubed, x squared, and just an x. So if it was linear, you would only see this one x. If it was quadratic, you would see this x squared. The polynomial is anything greater than that. So the domain is a set of all real numbers, and if the greatest exponent is even, the range is a set of all real numbers that satisfy the function, and the greatest exponent is odd. That means the range is a set of all numbers. So next I want to tell you about one-to-one functions, and sorry again for covering the graph up. But each value of x is exactly one value of y, and each value of y has exactly one value for x. And you can also use the vertical and horizontal line test. Like for functions itself, you can see if it's a function by the vertical line test. You can tell that it's one-to-one if you can also use the horizontal line test. So for instance, this right here I have showing that this is one-to-one because each x has a y. And unlike this one, showing that it's not one-to-one, this y has two x's. So therefore, it's not one-to-one. So if we were to look at a graph of this, you want to be able to do a horizontal line test. And for this parabola, if you were to draw vertical lines through all of this, you would see that there are two different y's for every x. That makes sense. Alright, so next I just want to tell you a little bit about trigonometric functions. So not that you have to memorize the unit circle, but the unit circle is a great thing to know. Just understand it basically, or if you know one quadrant, you can pretty much get the other quadrants. And so I do have this saying for you, just to remember about sine, cosine, tangent, and what quadrant they're positive in. And we're looking at quadrant as 1, 2, 3, and 4. So 1, 2, 3, and 4. So all students takes classes. So you can remember this because the all is to remember that each trigonometric sign in the first quadrant is positive. All are positive there. So then the S in students represents the sine function and its reciprocal in the second quadrant. The T in take represents the tangent function and its reciprocal in the third quadrant. And the C in classes represents the cosine function and its reciprocal, that it's going to be positive in the fourth quadrant. And so very lastly, I just want to show you the signs of all of these. I'm going to try to move myself up here. But these are just the graphs that I think are important for trigonometrics. So you want to make sure that you know sine and know that it basically starts at 0 and you find it maxes at 1. And cosine is right the opposite. It starts at 1, and then its max and mins are still at 1, but it starts at 1, not 0, compared to sine. And then a tangent, this is just an example, but a tangent is any time it touches somewhere at 1 point. So that's all for functions. Thank you.